versatile characteristics compared to multispectral and RGB image analysis, hyperspectral shows versatile characteristics, some sort of positive advantages compared to the rest of the two, such that it is optimally chosen to concentrate more because of having some advanced characteristics in various kinds of regions or various areas. So first of all, let me see the advantages or the characteristics which differs hyperspectral imaging with the rest. After that, we move with the research flow which we have to choose to get into hyperspectral imaging. After that, we will observe some recent papers on what topics they concentrated and what improvements they have shown in different areas. First of all, let me go through with the advantages or the research need with respect to hyperspectral imaging. So these are various characteristics of hyperspectral imaging, that is information richness, complex data analysis. So information richness represents, as sir already told, that hyperspectral imaging relates with giving very minute data in image analysis. Every minute data, every relevant data, every data is going to be reflected in image analysis. That represents richness in image. Every information is going to be get analyzed, or every information is going to be stored in image analysis with the help of hyperspectral imaging. So that is one of the versatile characteristic of hyperspectral imaging. After that, complex data analysis. As hyperspectral imaging relates with very high bandwidth wavelength information, so it can access very complex, nothing but very small color variation also can be identified by using hyperspectral imaging. So that is also one of the better advantage or better thing compared to multispectral and RGB image analysis. Next thing is improved accuracy and precision. So normally whenever we deal with image acquisition techniques or image processing techniques, accuracy and precision are the most important parameters to estimate the effectiveness of a word. So as hyperspectral relates with every minute relevant data, we can expect that multispectral imaging can reflect maximum efficiency, nothing but maximum amount of accuracy and maximum amount of precision compared to the existing techniques or compared to the lower level, we can say lower level techniques, that is multispectral and RGB image analysis. And next characteristic is application specific challenges. So rather than applying same colors or applying specific amount of wavelengths to a specific field, hyperspectral imaging allows to select specific wavelengths to specific field, nothing but in case of medical analysis, medical data analysis, a certain wavelengths are going to be used to estimate various results. Similarly, in case of mining, so some sort of wavelengths are going to be reflected, that relative sensors are going to be used to identify various characteristics at mining sector. Similarly, if the hyperspectral can be used at atmospheric conditions estimation, so certain wavelengths are going to be used for that specific field. As hyperspectral imaging is going to have huge amount of bandwidth, that allows it, that shows its importance to adopt specific different types of fields using hyperspectral image analysis. After that, integration with other technologies. So not only limiting to a specific field, hyperspectral imaging can be very much adapt to use various kinds of other technologies also. For that concern, in the last presentation, the last block which we observed is integration and validation. So that integration and validation supports to correlate with various other technologies also. So that is also one of the advantage that hyperspectral imaging offers. After that, optimization for real-time applications. So for various types of applications, some applications may need increment values, whereas some applications may need decrement values. Nothing but if you take VLSI circuits, so time has to be very much less, whereas it has to operate with fast. So we are going to represent the same parameter with reciprocal relativeness. So in the same way, some parameters may have to be get increased and some parameters has to be get decreased. So by using various segmentation techniques and classification techniques, wherever we want to add the color, we are going to add the color. Wherever we are going to decrease the colors, which are not necessary, we can decrease the color. So that kind of adaptability or that kind of advantages that hyperspectral imaging is going to be offered. So for that concern, for the process of optimization for various real-time applications, hyperspectral imaging can be very much useful. After that, interdisciplinary applications. All these relates to similar kind of applications that by using hyperspectral imaging, we can enhance the working areas because of having huge amount of bandwidth that it allows. So that is the importance of hyperspectral imaging. Along with that, it provides various advancements in sensor technology. So because of having the usage of hyperspectral imaging, scientists try to collaborate with, try to concentrate on sensors such that they have to accept or they have to process that higher level of wavelengths or lower level of wavelengths also. So that variation, in accordance with the variation happened in the technology, the same kind of changes has to be adopted by sensor technology also, because the initial stage of hyperspectral imaging technique is going to acquire the image. For that concern, various kinds of sensors or multiple types of sensors are going to get introduced to satisfy or to get real-time applications of this hyperspectral imaging. Along with that, various societal and economic impact on the society is going to be happen. Nothing but if we analyze the diseases as much accurate as possible, then we can try to save the life of a human being or any kind of living thing. So in the same manner we can observe in the olden days, if there was only one detection technique that we used to hear is X-ray. Now we are listening so many types of advanced techniques which can not only identify but also try to estimate what is the intensity. Even in corona also we have gone through with some scanning techniques like severity score. So severity score 1. So positive means positive, that's all. But how much amount of positiveness, whether it is just severity score 1, 2, 3, that kind of levels they classified. Nothing but in that way the hyperspectral imaging is going to get into and identify what is its severity level. So that gives a advantage in detecting the diseases and try to save the human lives. And also in opposite way we can observe that doctors society, not PhD doctors, health doctors are the only community who are going to get who are going to earn lots of money because of having these much advantageous techniques. So for a test they are going to take so much amount of money. So at the end of the day, there is a huge impact upon the society because of having tremendous changes happening in the technology. So that is all the need, that the necessity that offers to concentrate on hyperspectral imaging. Along with that, if we opt hyperspectral imaging, what advantages we can get? That is research importance in hyperspectral imaging. So we can improve remote sensing and earth observation, as it is going to give huge amount of accuracy, higher precision. We can estimate the earth surfaces, various atmospheric conditions as accurate as possible. So now also we can estimate that some cyclone is going to happen at a particular place and it is going to come onto the earth at a specific point, right? Before it is going to come onto the earth, the scientists are in a situation that they can estimate at which place it is going to land on the earth. So what is its wind intensity? So how much of damage it can done? So what early precautions we have to take? Like that we are going to estimate by using these kind of advanced techniques. So it depends upon the image analysis of the entire atmospheric structure. One can get a clear idea about what kind of damage it will do and how it moves like that. So that entire information we can get if we inculcate this hyperspectral imaging in atmospheric field. After that, scientific discovery and explanation. So, hyperspectral imaging enables scientists to explore, analyze composition of objects, material, so whatever. So, in that relative field, so many advantages can be provided with the help of scientists. Along with that, medical imaging and healthcare, so precision agriculture. So, by accurate identification of water levels, humidity levels, and various kinds of strength levels in the soil, one can easily estimate what kind of crop has to be suggested for the agriculturers, such that they can the plants can grow with respect to that environment, such that the farmers can get better crop yields. So rather than with huge estimation some other plants which are not suit to that earth environments, rather than choosing that kind of forms, so rather than giving a proper idea to the farmers so that your land characteristic is like this, so these crops will be helpful for you for the plantation. Like that kind of estimation also we get by using hyperspectral imaging. So in the area of agriculture also, hyperspectral imaging is going to give minute data such that we can get more advantages. After that, environmental monitoring and climate studies, defense and security applications. So in the previous slide, Sir also explained that by using hyperspectral imaging, we can estimate the drugs also in various situations like airports. By using image analysis only, the officers are going to detect what kind of prohibited material that a passenger is going to take or not. So rather than opening it, the initial examination is going to happen by using image analysis only. So it is happened by using this very high bandwidth hyperspectral imaging, such that depends upon the wavelengths the material, the drug is going to reflect. They can get an estimation that whether that material is a prohibited material or permissible material. So for that kind of security concerns also, this hyperspectral imaging is very much helpful. Not only with respect to drugs, we can also detect various kinds of metals. We often go through with the news that say a person from Singapore or Dubai caught by having 2 kgs of gold, 3 kgs of gold with some sort of techniques, by using some sort of techniques. So police caught them. Why means by using these very high bandwidth image processing techniques only, because those metals are going to respond for that specific wavelengths. By decoding that wavelengths, officers are going to get an idea that whether it is permissible material or not. So to get maximum security, along with various other applications like agriculture, mining, atmosphere, health, all these areas are going to be moved to another level by incorporating our hyperspectral imaging concept. So these are various important research exploration, technological advancements, data dimension, data. So all these are previous things which we gone through. So whenever as a researcher, if we opt the concept of hyperspectral imaging as a research area, so we have to follow specific steps which are called as research steps. Let me see what are the steps that we need to consider while we opt image acquisition techniques as a research topic. So the first step is we have to define our research objectives. So what is our objective? What is our main aim to do research? Whether it is related with disease identification or environmental analysis or any kind of other security concerns, or what kind of field we want to get into. It truly depends upon the candidate with his individual interest. So based on his individual interest, he has to get approximate objectives. So what I want to do. Okay, so that kind of consideration is called as defining research objective. After that, once getting a clear idea about what we have to do, based on what field we have to do the research, we have to collect the data which has been published earlier. So whatever the previous papers are there, so we have to gone through with all the standard publications, nothing but that are indexed in either in Scopus or Web of Science, that journals that has been ranked in Science Citation. So like that, some standard journals we have to follow. Based on those journals, we have to get an approximation that our research area has been implemented to that particular level, so that we can get a clear idea that if there is a scope to move further or not. For example, if a research area is achieved with an accuracy of 100%, we can't go further. Why? Because whatever thing that was there, it has already achieved. So there is no scope for us to move forward. So we have to identify our research objectives in such a way that there should be something to do rather than there is already done. Okay? So that we can get by collecting huge number of papers from standard journals or standard publications and getting an idea that how much progressive the research is in that specific field. So that entire thing comes under literature review. Collecting the data, analyzing the data and getting an idea about our objectives at what level they have been achieved. So that is called as literature review. After that, so here we are discussing about hyperspectral imaging. For that concern, we representing it as understanding hyperspectral imaging basics. So without considering basics, we can't move forward, right? So for that concern, we have to get a clear idea about hyperspectral imaging. What is its bandwidth? How it is going to be get identified? So what are the basic blocks? So this kind of basic information is very much necessary to do research with respect to hyperspectral imaging. So after that, even in the blocks also, the first thing is data acquisition or image acquisition. After that, in data acquisition, the basic fundamental block is lens. After lens, we are going to have some sensors to acquire the image in an original manner. So for that concern, while doing research also, we have to have the basic idea about hyperspectral imaging. Along with that, we should have a clear idea about the sensors, especially hyperspectral imaging sensors which work on that specific, that is 350 nanometer to 15,000 nanometer bandwidth sensors, how they are going to work, which sensors are suitable with respect to that bandwidth. So we have to get a specular idea about those sensors. After that, data acquisition planning. I think what kind of data sets we have to take. For example, if we are working upon medical field, so there are some sort of data sets that are freely available. Why? Because if we directly can't go to either doctors or any kind of hospitals to get the details of patients, right? So rather than, we have to take some standard data sets which are freely available data sets in internet, such that we can apply our research on them and get the results such that they can be comparable with the previous works. Okay, for that concern, we should have some data acquisition planning. So what kind of data we are doing the research, whether they are related to medical images or atmospheric images, nothing but satellite images, or else there are some images related to mining. So we have to collect the data first, that fundamental data which we are doing our research on it. So we have to get an idea that how they will be available. Okay, that is data acquisition. After that, data processing. After getting that idea, we move further. Nothing but after data acquisition, we are going to do pre-processing. Pre-processing is what? Removing noise. How can we remove noise? By using filters. So rather than using high pass, low pass, band limited, all those are some basic filters, right? So rather than that, we are going to use some other filters like Wiener filter. Okay, so some advanced kind of filters we are going to use on images to remove the noises or remove unwanted pixels in that image. So that kind of thing we need to plan. So in previous, some other person has been used band pass filter. Now I am going to use band limited filter. Like that, there will be somewhat differentiation with respect to previous work, and that differentiation has to lead maximum accuracy or maximum precision. Then only our research will be get identified. So before that, after getting image, we have to do some processing, or we have to do some process upon that image. So what kind of processing we are going to do on that image? Nothing but filtering, classification, segmentation. After that, after segmentation, we are going to get accurate results. So these are various stages where the researcher is going to show his novelty, right? Some set of scholars, they use some low pass filter with the combination of SVM with the combination of K-means algorithm. By using these three steps, he got some results. So as a new researcher, I gone through with previous papers that I found that he used some sort of filter, some sort of segmentation technique, some sort of algorithm. By using these three combinations, he generated some sort of results. But as a new researcher, I have to replace the things. I have to show the novelty in terms of these techniques such that there is no other place that we can show the result. If you observe the block diagram of the entire hyperspectral imaging concept, it can be broadly classified as three stages. One is getting the data, second one processing the data, and third thing is observing the output and giving proper suggestions. So these three stages. So we can't do any changes at taking the data because it is constant. Simultaneously generating data also, it is also constant. It is going to give some output. By observing the output, we can give suggestions. Okay, only the place the researcher can do his research is processing. How he do the processing is going to show the difference. So based on that, here in our hyperspectral imaging, the way the filter the researcher used, the type of segmentation technique, the type of segment classification technique he used, the kind of algorithm that he used. So all the combination of these things made the researcher separate from the previous works. So one should have the fundamentals about basics and novelty about his techniques. By the combination of these three, he can show the difference at the output. So these are the steps that represents all these process. That is getting the data, that is data acquisition and processing it, and image analyzing it. All these relates to the same thing. After that, how he can do it? So practically a researcher can't do all these things. Practically he can't get a patient and take a X-ray or whatever the input images he can't take directly, right? So for that reason, some mathematical some software simulation tools are there to get virtual filters, to get virtual optimization techniques to implement through them and get some estimated results. So that what are the softwares that are related to our hyperspectral imaging concept? One should has to know. So rather than taking image analysis and doing it with, however it is possible by some complex steps, but if you want to proceed simple, we can't adopt VLSI software tools and try to apply image and as input and generating the output is a somewhat complex thing. So it doesn't make sense. So to do so, we should have a clear idea about the softwares which are going to accept images as input and generating the corresponding output. If you are best at MATLAB coding, so then it is easy to acquire images from as input and processing it by using various kinds of filtering techniques, segmentation and various kinds of processing techniques, and estimate the results such that we can compare it with previous ones. So all these are the basic things that we need a researcher has to go through with whenever he deals with hyperspectral imaging. That is software tools, ground truth data collection, methodology development, data analysis and interpretation, documentation and reporting. Once he get optimum results, so he has to do documentation such that the combination of this filter, this segmentation technique or with the help of this optimization technique, I got so and so results. So accuracy is this much, precision is this much, simultaneously processing speed is this much. So along with that, it is somewhat convenient to the patients, with less cost we can implement. So these kind of characteristics he has to justify by using some documentation or by publishing in a standard journal also. So after peer review and collaboration, continuous learning. So all these are representative the research step, different types of research steps that a researcher has to go through to achieve a novel method in hyperspectral imaging. So after that, in case of after completion of his research, if you want to go further, the first fundamental thing is continuous learning is the fundamental thing. However, he has to identify emerging technologies. Any other researchers who are doing go further than his research. So he has to continuously observe that what much advancements have happened in that particular field. Along with that, he has to collaborate with various professionals, healthcare professionals, nothing but to get accurate value. So whatever the researcher is going to propose, it is up to the process of simulation. We can say that as estimated results, but practically it is not going to be achieved at that level. So how much the concepts that are coming as theoretical part, how much it is going to be practical. So how much deviation is there, or how much threshold level is there in between the theoretical implemented things and the practical one. If he goes like this, then he get a clear idea about the entire research work. So these are different papers that we gathered for our hyperspectral imaging concept. So authors Zaman Ahmad and Malik. So they proposed analysis of hyperspectral data development approach for document images. So which is published in Census Journal in 2023, who reviewed various kinds of documents by using hyperspectral data. So these authors reviewed various kinds of data sets and they have proposed a cumulative report in this journal. After that, authors Zhu Ling and Wang, they proposed a document with the title Collaborative Hyperspectral Image Processing using Satellite Edge Computing. So this research is related to atmospheric observations. So they conducted some atmospheric observations, and their observation lead to envision to provide an orbit processing of sensed data to save the scale of terrestrial satellite communication resources and support mission critical services. So with respect to communication between satellites, they did some research and they investigate the trade-offs between different spectrum bands and considering the impact of noise, and they address various uncertainties in hyperspectral imaging data. So another journal is proposed by Yoon with the title of Hyperspectral Imaging for Clinical Applications. So these scientists proposed a mechanism called Principles of Hyperspectral Imaging, where the image analysis methods and clinical applications for disease diagnosis and surgical guidance have been presented in this paper. However, this review summarizes the basic principle of HSI and optical systems, deep learning based image analysis and clinical applications of HSI. However, what the thing that they miss is they considering the research exponential growth of the clinical HSI methods, whereas HSI will become a versatile clinical tool in disease diagnosis and surgical guidance in the near future. So it is another paper which is proposed with respect to new hyperspectral image classification methods based on spatial features. So it is published in Scientific Reports in the year of 2022. So they used two-dimensional Gabor filter with random patch convolution for feature extraction, PCA and LDA for dimensionality reduction, and SVM for classification. So here you can observe various combinations for processing. So they used Gabor filter, right? Along with that they used not only PCA, along with the PCA they used LDA. Along with that they used SVM classifier for classification. So this combination is going to yield them some optimum results. But that combination makes them unique compared to the rest of the authors. So in such a way, a researcher has to plan some permutations and combinations which can generate optimum results, or we can say which can generate maximum results. So here it is also another paper titled with dual stage approach toward hyperspectral image with super resolution. So it represents the 5 bands with high similarity in a certain spectral range